Hello everyone, in today's video we're going to go over 5 Python advanced tips that will help you to do more Python efficient coding and help with Python code optimization. So let's jump in. Number 1 would be Python loop optimization using range. It's a very simple concept. I'm first going to show you how we traditionally used to do loop in Python. So we say for I and we open brackets and we put in the numbers that we wanted to loop over. And then let's say we're going to print it here. Just for sake of demonstration, let's run it and see what's going to happen. Yep, we'll see those numbers get printed here. We looped over them and we printed them one by one. There is a better way to do this, easier way. We could say for I in range and we just define the number how many times we want to loop. So if we pass I here, we should get the same result. So remember that this will start from 0. We can also define the first number if you want to, or we can define the start, stop, and step arguments. So let's do that in the next one actually, just to demonstrate. Okay, for I in range. We want to start from 1, go to 10, and we want to jump every 2. So we're going to skip every other number. So this should be 1, 3, 5, 7, 9. Okay. Okay, so the range function makes it clear that you're iterating from like 0 to 4. It is more intuitive than listing out each number. Using range is more scalable, and if you need to iterate over a large number of numbers, it just simplify our code, our argument without modifying the list. Range is more memory efficient, so like having all 0, 1, 2, 3, 4, it takes up more memory space than just having range 5. Okay, now let's go over to our second tip. Python default values in functions. I'm gonna just write the code. First, let's have a comment here. Just keep everything organized. I like everything to be organized. Number 2, default values. Okay, we're gonna have function here. This is the how we do it traditionally. Let's say def greet name none, or we can just remove the name, but for our example we're gonna need it. So if name is none, then name is equal to guest, and we want to print hello name. Let's run it. Okay, actually we need to call it first before running it. Alright, hello guest. So we didn't pass anything, and the name was none. We didn't need to pass anything actually. So, but there's a better way to have a default values. We're just gonna say diff, let's say same name, greet, and we're gonna say name guest. Okay. So when we give value here, this will be used as the default one. So if we don't pass any values, this one will be used. We didn't have to go over all that conditional statement if name is none or whatever. Okay, so that would be sufficient enough. Just put it in the argument. Okay, let's run this. Let's call it first. Great. Now I want to pass. Nah, it's okay. So run hello guest. See, we have two now. The first one is for the first. Actually, we're calling it twice. That's why we're getting two hello guests. Run it now. Yep. So we didn't pass anything. We just called. And there was a default value in there. We didn't have to define it separately like this one. Okay, let's remove it. And still getting the same result. Let's also give it a name. If we give it a name, it's not going to use the guest anymore because that was the default one. Run Alice. Alright, great. Okay, so setting a default value directly in the function definition, it simplifies the code. There's no need for additional conditional check inside the function, so we don't need to make sure if the value is provided or not. And also is more readable. It's clear that the guess is the default value. The optimized method is clearer and easier to understand, and also is less code. So it reduces the number of lines and it eliminates the need of using if statements. Alright, now let's go to the next tip. Python sublist extraction or slicing. This is what we call it. Okay, let's put a comment here. 3 slicing. Let's say we have a list and we want to read its value. We usually do that using a loop like below. Let's first create the list, numbers equal brackets 0, 1, 2, 3, 4, 5. We're gonna have another one called slice. It'll be an empty one. We want to append after looping to this one. So for I in range, okay, in range 1 to 4, let's say. Okay, slice append numbers I. Print sliced. Okay, let's go and see what is happening now. Yeah, we're gonna comment this out. Run. Okay, we're getting an error. What happened here? Okay, we didn't remove this line. Let's just remove all of it. Run. Alright, 1, 2, 3. So we start from 1 to 4. But there's a much easier way. Let's do that. We're gonna go down. Print numbers 1. Okay, numbers brackets 1, 4. This will print index number 1 to 4. See? Same thing. So the list slicing reduces multiple line of code to a single line. It's more readable. It clearly shows that the subset being accessed. So it shows that we're trying to access the elements in the numbers list. And the slicing is just more efficient because it's leverage built-in list operations, avoiding the overhead of a loop and manual append operations. So that's why we use that. Okay, let's remove these. Number 4, enumerate. Okay, in this section we're going to have Python enumerate tutorial. Let's say that we have a list that we want to loop and track every index at the same time. The usual way is just using a loop, just a regular loop like the one we're going to create now. First we need the list. I'm going to say Charlie. So we have a list of names. And also we need a variable for an index, 0. You want to use this as a counter or tracker, whatever you prefer to call it. So for name, in names, print index and name. And now we need to increase the index so we keep tracking it. Run. Yep, we can see it. But there's a better way, is to enumerate. Enumerate is a built-in function that provides us index tracking. So our code will look like this. We're going to use enumerate names, that's all. Print I and also name. So I represent the index number and the name represent our names list. So Enumerate automatically handles index tracking. It eliminates the need to manually increment an index variable. As the cleaner code, the optimized method is cleaner and more concise. It reduces potential errors related to manual index management, and it's more readable. Okay, let's delete this. And tip number 5, list comprehension tutorial. List comprehensions. Let's say we have an empty list and we want to append the result of some operation to it, like the one we're going to create right now. Squares equal to an empty list. Then we're going to iterate 10 times. And we're going to say squares dot append x2. All right. So let's print the result of this operation. Run. All right. We'll see the x squared 2 result appended to the list. But there's a way easier way to do that. We just need to say squares. Let's just squares 1. Make it a little different. We're gonna say x squared 2 for x in range 10. So I used an inline loop inside of the list, and then we print it here. Run. Same result. So the list comprehensions combine the loop and the list construction into a single compact line of code. The intent is clear and immediately understandable. You can see at a glance that is creating a list of squares, and its list comprehensions are often faster than traditional loops because they're optimized for these specific operations in Python. And here you guys have it. The 5 features we discussed: loop range, default function values, slicing, enumerate, and list comprehensions. All of these will help us to have a cleaner, more readable application. They will reduce the amount of coding, save memory, and boost your Python skills. I really hope you enjoyed watching this video. If you did, please give me a like, subscribe, or give me a comment. I would really appreciate that. Happy coding, guys.